Something extraordinary just happened on Mars. For the first time in history, a machine built by humans, sitting on another planet, may have captured a real image of an object from another star system. NASA's Perseverance Rover, quietly scanning the Martian night sky, recorded something no one expected to see: a faint, elongated streak moving across the darkness at incredible speed. At first glance, it looked like nothing more than a blur, a trick of light, maybe a cosmic ray strike on the camera sensor. But when mission engineers reviewed the data, they noticed something strange. The streak wasn't random. It had structure. It moved with a trajectory consistent with a real, physical object slicing through the Martian atmosphere's thin upper edge at a velocity far beyond anything known to orbit Mars. The timing matched perfectly with the predicted passage of an interstellar visitor known as 3I/Atlas, the third confirmed object from beyond our solar system ever observed by humanity. Only two others have been confirmed before it: Oumuamua in 2017 and Borisov in 2019. But this time, the image wasn't captured from Earth. It was captured from Mars itself, by a rover designed to explore rocks, not chase cosmic mysteries. Imagine that for a second. A robotic explorer 225 million kilometers away, looking up into the sky of another world, and recording a ghostly visitor racing between the stars. The discovery wasn't even part of the rover's mission plan. Perseverance's night sky cameras were running as part of a routine sky calibration test. The data was only checked days later, when one frame stopped the team cold. If you love exploring the cosmos, subscribe now and like this video for more incredible space discoveries. Something had moved across the frame at over 60 kilometers per second, faster than any known asteroid or Martian satellite. And yet, it wasn't just the speed that puzzled scientists. The light signature didn't match that of dust, debris, or a shooting star. It was colder, more reflective, and eerily stable, as if the object had a defined surface rather than a trail of vapor. Speculation spread fast. Was this really 3I/Atlas? Could Mars have just witnessed an interstellar traveler from a completely different star system, one that had journeyed for millions, maybe billions of years, before brushing past our sun? If confirmed, this would be a cosmic first, the first interstellar object ever photographed from the surface of another planet. Think about that. Humanity's reach would no longer be limited to observing the universe from Earth. For the first time, another world had become an observatory. But this isn't just about an image. It's about what that image means. If Perseverance truly captured 3I/Atlas, it changes everything we know about what's possible. It proves that interstellar visitors can be detected not only from Earth, but from other planets too, turning the entire solar system into a network of cosmic watchtowers. And maybe, just maybe, this faint streak over the Martian horizon wasn't just a random blur. Maybe it was the first whisper of something far older, far stranger, and far beyond anything we've ever seen before. It all began quietly, on a cold winter night in July 2025. At the top of a mountain in Chile, the ATLAS survey, a network of telescopes designed to spot dangerous asteroids, picked up something odd. A faint, fast-moving object streaked across the star field in a way that didn't make sense. Its speed was too high, its path too steep. Within hours, astronomers realized this wasn't just another rock orbiting the sun. This object was on a hyperbolic trajectory, a path that doesn't loop back toward the sun like every planet, comet, or asteroid we know. Instead, it was escaping. It had entered our solar system from the cold depths between the stars, and one day, it would leave again, forever. They named it 3I/Atlas, the 3I marking it as the third interstellar object ever confirmed by humanity. But even in those early observations, 3I/Atlas stood out from anything seen before. Its velocity relative to the sun was nearly 90 kilometers per second, faster than any known comet or asteroid in the solar system. It wasn't just visiting, it was flying through as if our sun was barely there. The more data astronomers gathered, the stranger it became. Its brightness didn't behave like a typical comet. Instead of gradually brightening as it neared the sun, 3I/Atlas flickered unpredictably, sometimes glowing, sometimes dimming, almost like it was rotating or changing shape. No known model fit its light curve perfectly. It was as if the object was tumbling, reflecting sunlight in uneven bursts. Early spectroscopic analysis revealed something even more intriguing. Its chemical signature didn't match the icy comets we've seen before. Most comets release water vapor, carbon dioxide, and dust as they heat up, but 3I/Atlas seemed to have very little water and an unusually high ratio of carbon dioxide and complex hydrocarbons. That made scientists wonder, where did this thing come from? Some traced its incoming trajectory backward through time and space, and found it likely originated from far beyond the outer edges of any known star system, perhaps a young stellar nursery a few hundred light-years away. Others speculated it might even be debris ejected from a dying star or the remnant of a long-destroyed planetary system. And yet, there was one more mystery. 3I/Atlas's spin rate and reflectivity seemed to shift slightly each time it was observed. That hinted at a complex shape, possibly elongated, much like the infamous Oumuamua, the first interstellar object ever discovered in 2017. But this time, the stakes were higher. Because this object wasn't just visible from Earth, it was heading on a path that would take it past Mars. That meant, for the first time ever, humanity would be able to observe an interstellar visitor from two worlds at once. No one could have predicted what would happen next. As 3I/Atlas approached the red planet, scientists expected just another data point, another streak of light across a telescope's field. But what the Perseverance Rover captured on that October night in 2025 changed everything. On October 4th, 2025, deep in the dusty silence of Jezero Crater, Perseverance's cameras turned their gaze toward the stars for what was supposed to be a simple calibration test. No one expected history to unfold in a single frame. When the images came down from Mars, one photograph immediately stood out. A long, luminous stripe cutting across the Martian night sky. It wasn't a meteor. It wasn't a glitch that engineers could easily explain away. It was something else. The team checked the exposure time, the camera's motion, even the timing of cosmic ray hits, but nothing matched what they were seeing. The streak had the faint halo of reflected sunlight, consistent with a real moving object, not a random artifact. Its angle aligned perfectly with the predicted flight path of 3I/Atlas as it passed near Mars at more than 60 kilometers per second. A perfect match. Scientists were stunned. Some insisted it had to be a motion blur, the object racing so fast during a long exposure that the camera recorded a stretched-out trace of its journey. But others weren't so sure. Zoomed in, the streak wasn't uniform. There were faint bands of brightness, rhythmic variations as if light was bouncing off different surfaces. Could this be an irregular object rotating in space? Or, even more strangely, could it be reflecting light in pulses, almost as though it were metallic? The debate erupted online. Astronomers, engineers, and skeptics all joined in. NASA kept a cautious tone, calling it a likely exposure artifact. Yet they couldn't deny that the streak's position, timing, and brightness matched the interstellar object's calculated location with uncanny precision. Some independent analysts even noticed that the brightness spike at one end of the stripe coincided with a momentary flare, so brief that it lasted less than a second, but bright enough to saturate the camera's sensor. That single flash became the heart of the mystery. Was it sunlight glinting off ice or metal? Or was it something even stranger, a controlled reflection, a signal, an echo from something that wasn't meant to be seen? While official explanations leaned toward physics and optics, curiosity refused to die. Because if this wasn't just a smear of light, then Perseverance had done something no machine had ever done before. It had photographed an interstellar visitor from another world's surface. Mars, once the target of human exploration, had, for the first time, become an observer itself, watching a traveler from the stars glide silently across its alien sky. As soon as the image went public, the scientific community erupted in debate. To many researchers, it was a thrilling mystery, but to others, it was a potential trap. The streak could be the result of countless natural or technical factors, And the last thing scientists wanted was another wave of viral claims about alien artifacts. Astrophysicist Avi Loeb, well known for his studies of interstellar objects, was one of the first to weigh in. He argued that the streak was most likely a technical artifact, a product of exposure timing, sensor noise, or even the way light interacts with the thin Martian atmosphere during long exposures. According to him, extraordinary claims require extraordinary evidence, and this single image, fascinating as it was, couldn't prove anything beyond doubt. But not everyone agreed. Others pointed out that the structure of the light trail didn't behave like a simple camera smear. It had subtle variations, fluctuations in brightness and small bends along its length that didn't match any known imaging anomaly. It looked like something solid was rotating or reflecting light unevenly as it moved. The data team rechecked the rover's logs, comparing power fluctuations, temperature readings, and lens calibration files. Everything was normal. Nothing suggested a hardware glitch. And that's where the intrigue deepened. If the equipment was functioning perfectly, then what exactly had Perseverance seen? Online, speculation exploded. Some believed it was a fragment of natural rock coated with reflective compounds, something ejected from another solar system and tumbling through space. Others went further, suggesting that it could be an artificial object, a piece of interstellar debris, or even a probe. They pointed to the light pulse caught in the image as possible evidence of controlled reflection, the kind of glint you'd expect from a flat, metallic surface catching sunlight at just the right angle. Meanwhile, scientists scrambled to remain grounded. Teams at JPL and NASA analyzed the image pixel by pixel, trying to reproduce the effect with simulations. Some managed to mimic the streak by adjusting exposure times and camera movement, while others couldn't quite replicate the exact pattern. Even after weeks of study, no one could definitively say whether it was a trick of light or a glimpse of something truly extraordinary. But one fact remained undeniable. The timing and position of the streak lined up perfectly with 3IATLAS's trajectory as it crossed Mars' orbital plane. Whether it was natural or not, it was real, and it had been seen. In that single moment, Mars had become more than a dusty planet under robotic exploration. It had become a witness, a silent observer of something that may have journeyed across the galaxy to pass, for just a heartbeat, through our small corner of the universe. The deeper scientists looked into 3I/Atlas, the stranger it became. What was supposed to be a simple comet turned out to break almost every rule in the book. When telescopes around the world captured its spectroscopic signature, the data came back puzzling. Unlike normal comets, which are rich in water ice and dust, this one showed very little H2O, almost none. Instead, it was dominated by carbon dioxide and complex organic molecules, a composition rarely seen even in the most extreme outer solar system objects. It wasn't just dry, it was different. Its surface seemed coated with materials that absorbed sunlight in strange ways, reflecting light unevenly and giving it a fluctuating brightness pattern. When astronomers examined the polarization data, the way light waves scatter after bouncing off a surface, they noticed something even more curious. The polarization curve didn't match any known comet, asteroid, or icy body. It was sharper, more metallic, almost as though the surface particles were unusually smooth or structured. Some suggested that the grains of dust covering 3I/Atlas weren't random at all, but aligned, possibly by magnetism or by the way the object formed in another star system. This raised an unsettling possibility. Maybe 3I/Atlas wasn't built like the comets born in our solar system. Maybe it had formed in an entirely different kind of environment, one where chemistry, temperature, and starlight were nothing like what we know here. A few researchers even proposed that the composition pointed to artificial processing, the residue of manufactured materials or ancient debris from a destroyed world. That idea was controversial, but impossible to rule out completely. Adding to the mystery, as 3I/Atlas approached the inner solar system, it didn't behave like a normal comet under solar heating. Instead of flaring up and shedding gas, it pulsed, brief surges of brightness followed by eerie calm. It was as if the object was venting in bursts, controlled or patterned rather than chaotic. Every few hours, telescopes recorded tiny fluctuations, almost like a heartbeat echoing across space. And then came the color. Most comets reflect a pale blue-white glow from icy dust, but 3I/Atlas had a subtle reddish hue, something that suggested complex hydrocarbons or tholins, chemicals that form after long exposure to cosmic radiation. That reddish tint made it even more alien, as if it had drifted through interstellar space for millions of years, its surface slowly burned and hardened by the endless starlight between worlds.